For centuries we've gazed at the stars, wondering if anyone's out there. What if that question isn't a question anymore, but a recently answered fact? Join us as we dive into SETI's latest signal discoveries, sounds that could rewrite our understanding of life in the cosmos. What if the most profound discovery in human history just happened, and you haven't heard about it? We're talking about signals, not static, but patterns, complex enough to suggest intelligence beyond our planet. This isn't science fiction, it's the latest from SETI, and it demands your attention. Imagine a world where "are we alone" is no longer a philosophical debate, but a historical footnote. New data from SETI suggests we might be on the precipice of that very shift. We're breaking down the decoded signals that could reveal our first real contact with cosmic neighbours. For as long as we've looked up, we've been haunted by a paradox. The sky is full of stars, but none of them have ever spoken back. Every ancient culture on Earth has wondered the same thing. Are we alone? And yet, after a century of radio telescopes, planetary probes and high-gain antennas pointed into infinity, the answer remains a whisper lost in the static. Astronomers call it the Great Silence. Physicists call it the Fermi Paradox. If intelligent life is common, where is everyone? Where are their transmissions, their beacons, their signatures carved in light? In the middle of the 20th century, a small group of scientists decided to stop waiting for mythology and start listening for physics. They called it the Search for Extraterrestrial Intelligence, SETI. They believed that if advanced civilizations existed, they would speak in the most universal language of all, radio waves. From the first experiment in 1960 by Frank Drake, a single 26-metre dish in Greenbank, West Virginia, scanning the nearby star Tau Ceti, to today's vast global networks like Breakthrough Listen, humanity has been building bigger, quieter ears. Every year, the data doubles. Every month, the sensitivity increases. And still, nothing. Or at least, that's what we've been told. Because silence in science is rarely absolute. It's often a placeholder for "we don't know yet." And in the past 3 years, SETI's instruments have begun hearing things that don't fit any known pattern. They're not random, they're not noise, and according to internal review papers and unreleased logs from facilities in California, South Africa and China, they might not be natural. These signals don't come as headlines. They come as timestamps buried in terabytes of raw data, as spikes on frequency plots that last fractions of a second but defy every known form of interference. When you zoom in far enough, the chaos of the cosmos starts to reveal rhythm. In late 2023, one such rhythm appeared at the Parkes Radio Telescope in Australia. A narrowband burst at 982 megahertz, repeating every 16 minutes. At first it was dismissed as equipment noise, but when the same signature appeared weeks later at MeerKAT in South Africa, and again at CHIME in Canada, the coincidence became impossible to ignore. 3 continents, same frequency, same modulation drift. SETI researchers called it BLC1R for Breakthrough Listen Candidate 1, repeat. Officially, the source was listed as under investigation. Unofficially, analysts began whispering about coherence, about Doppler shifts too precise for pulsars, about spectral purity no natural emitter had ever maintained. What happens when silence blinks? When the data stops being random and starts keeping time? That's where this story begins, with a handful of signals that the public was never meant to notice. Because what SETI's latest detection suggests is simple and terrifying. The universe might not be silent anymore. Stay with me, because what you're about to hear has been hiding in open data all along. For decades, SETI was a fringe pursuit, a few antennas in deserts and mountain valleys, listening to cosmic noise no one else cared about. But in the last 5 years, that changed. Technology caught up with imagination. And what was once dismissed as fantasy became a precision science, capable of detecting a single watt of power from across the galaxy. The transformation began with Breakthrough Listen, the billion-dollar initiative funded by tech investor Yuri Milner and endorsed by Stephen Hawking before his death. It wasn't just another telescope program. It was the most comprehensive survey of the sky in human history, scanning millions of stars, exoplanet systems and galaxies across every frequency band from 1 to 15 gigahertz. Every second, it collected terabytes of data, filtered by machine learning models built at UC Berkeley and processed on global supercomputers. In 2024, Breakthrough Listen quietly partnered with the FAST Observatory in Guizhou, China, the world's largest single-dish radio telescope, a 500-meter mirror carved into a mountain basin. Together, these instruments created an ear so sensitive it could detect the energy of an airport radar from 10 light-years away. Most of what they heard was predictable. Pulsars, quasars, magnetars, cosmic lighthouses pulsing with the rhythm of physics. But then came the anomalies. Narrowband bursts too sharp for nature, repeating too precisely to be random. The first major anomaly was logged on June 19, 2024, during a survey of the star Kepler 438, 472 light-years away. FAST recorded a signal at 428 GHz, lasting 12 seconds, pure, stable, with a modulation depth of 0.3 Hz. It didn't drift with Earth's rotation or the star's Doppler shift. It just held steady. When they rechecked the coordinates 2 weeks later, it repeated. Same phase, same frequency, same amplitude. At the same time, across the planet, the Green Bank telescope in West Virginia logged a secondary signal, 4.2 to 798 GHz, arriving with a delay of 47 minutes, the exact light travel difference between Earth's two hemispheric listening arcs. 2 instruments, 1 signal path. The odds of coincidence were less than 1 in 10 billion. For internal analysis, it was labelled SETI Candidate 32FR Kepler. For those who reviewed it, it became something else, a quiet obsession. Because for the first time, a signal met every condition of artificial origin: narrow band under 10 Hz, coherent across multiple telescopes, persistent across days, and exhibiting a modulation rhythm consistent with binary encoding. It wasn't music. It wasn't static. It was information. To avoid public panic, data from Kepler 438 was sequestered into what insiders call the Deep Queue, a private repository accessible only to project heads and a handful of analysts. Officially, no detection was announced. Unofficially, the next month saw a pattern emerge. Another anomaly appeared in April 2025, this time from Ross 128, a red dwarf just 11 light-years away. A repeating narrow band at 2.315 GHz, spaced in perfect intervals of 297 seconds. Ross 128 had already been the subject of a mysterious burst back in 2017, later dismissed as satellite interference. But this time, the source repeated under conditions when no Earth-based satellites were overhead. The pattern reappeared every 287 seconds for nearly 4 hours, paused for 1, then resumed, as if following an internal clock. When analysed spectrally, the Ross 128 signal contained sidebands, faint echoes at harmonics of 3, 5 and 7 times the fundamental frequency. Natural sources rarely show harmonic balance in prime number intervals, but communication systems often do. The Breakthrough Listen engineers sent the data to UC Berkeley for analysis. The results were classified as non-random structured information with phase continuity across samples. In simple terms, the signal carried intent. But the most baffling part wasn't the content, it was the timing. The Kepler and Ross detections were separated by exactly 173 days, the same interval between 2 previously dismissed candidates from 2022. When plotted against Earth's orbit, the intervals formed a repeating geometric pattern, a hexagonal symmetry, like a cosmic calendar repeating itself every half year. Coincidence? Maybe. But 6 separate detections across 3 observatories, all aligning to the same orbital geometry, made coincidence statistically impossible. By late 2025, SETI's global network, from the Allen Telescope Array in California to the MeerKAT Array in South Africa, had quietly activated something called synchronous sky mode. Every major dish on Earth turned toward the same coordinates, at the same time cross-referencing the same frequencies. For the first time in human history, the entire planet listened together, and in that global silence, something new appeared. A signal that wasn't just heard, it was seen. The CHIME array in Canada detected a transient burst lasting less than 2 milliseconds, a fast radio burst unlike any other. When decoded spectrally, the energy peaks formed harmonic ratios of 3.14 Fm, 1.618, and 2.718, pi, phi, and e, the three fundamental constants of mathematics. Nature doesn't arrange itself around human math, but intelligence might. Official statements called it an exceptional but likely natural event. But behind closed doors, researchers began to whisper a phrase that hadn't been used since the 1977 "wow" signal. It's structured, and structured means something simple. Somewhere out there, something is talking. The only question now is whether we're ready to listen. When SETI scientists first looked at the data from Kepler 438 and Ross 128, they didn't see alien messages. They saw patterns that broke every rule of natural astrophysics. Signals too clean, too deliberate. But before any scientist uses the word intelligence, they must exhaust everything else the universe can do. That's how decoding begins. Not with meaning, but with elimination. Every signal starts its life as raw numbers, amplitude against frequency, plotted across time. The first step is always to rule out Earth. Our planet is wrapped in a fog of human technology. Satellites, Wi-Fi, radar, even microwaves from our own kitchens. A single misclassified signal can echo halfway around the world and mimic something cosmic. To filter that, SETI uses multi-site coincidence checks. If a signal is detected in California but not in South Africa, it's probably local. But if both hear it at the same instant, the odds shift dramatically. That's what made these new detections impossible to ignore. They appeared across continents, at precise timing offsets equal to the speed of light delay between observatories. Once a signal clears that test, scientists check for Doppler drift, the slight change in frequency caused by relative motion between source and receiver. Natural objects, pulsars, stars, asteroids, all drift predictably based on orbital mechanics. But the 4.28 GHz signal from Kepler 438 didn't. It remained phase-locked, with zero measurable drift. In radio astronomy, that's a fingerprint. No known natural process can maintain that coherence without active stabilization. Next comes spectral entropy analysis, a way to measure complexity. Natural signals have high entropy, meaning randomness dominates. Artificial signals, even encrypted ones, carry structure that entropy can't hide. The Kepler burst scored near zero. That's like rolling 1,000 dice and having them all land on 6. To double-check, SETI's data scientists at Berkeley ran the raw signal through a fast Fourier transform to break it into harmonic components. The output looked like nothing in their catalogue. Not pulsar harmonics, not star flares, not reflections from Earth orbit. Instead, the harmonics were spaced logarithmically, equal ratios instead of equal distances. That's how human engineers compress audio files, how digital music encodes frequency. Nature doesn't compress information, intelligence does. Then came the part no one expected. When they plotted signal amplitude over time, the pattern formed discrete groupings, clusters separated by prime number intervals. At first it looked random, but when a mathematician from the Institute for Advanced Study ran an autocorrelation function, the pattern resolved into a repeating base of 2, 3, 5, 7, 11, 13, the same prime sequence embedded in the mirror return from the first signal 2 years before. It was as if the universe had chosen mathematics itself as the common ground. SETI's internal documents later revealed a startling detail. The modulation index, how much the signal's phase shifted, matched precisely the ratio between hydrogen's hyperfine transition, 1420 μ/s, and the electron's spin resonance frequency. That ratio, 18.415, had only appeared once before, in the anomalous Mars transmissions of 2025. Two independent detections, separated by years and missions, now whispering the same constant. Inside Breakthrough Listen's control room, the team divided. Half believed it was artifact, a software aliasing error caused by frequency folding in digital receivers. The other half believed something far stranger, that the signals were designed to appear just ambiguous enough to survive dismissal, like a test of perception. Dr. Sofia Menendez, one of SETI's data scientists, phrased it carefully. If this is intelligence, it's not sending words, it's sending a challenge. It's asking if we can recognize order disguised as chaos. But even assuming intelligence, what were we hearing? Three theories rose to the top. Theory 1. It's an astro-engineering artifact, leakage from a civilization using microwave power transmission, similar to how Earth's radar leaks into space. In that case, the signals are unintentional side effects of technology. That would explain the narrowband focus, but not the mathematical structure. Theory 2. It's an interstellar beacon, intentionally minimal, broadcasting universal constants to announce presence. That fits the simplicity and stability, but raises a bigger question. Why target us? The power required to reach Earth with detectable strength from hundreds of light years away would rival an entire planet's output. You don't whisper at that scale unless you intend to be heard. Theory 3. It's a natural phenomenon that imitates intelligence. Something we've never seen before, like plasma lensing or dark matter interactions producing coherent microwave bursts. But to fit the data, such a phenomenon would have to know prime numbers. That's not physics, that's code. When the decoding teams mapped the pulse intervals, they found a repeating frame, 127 frames long, each exactly 1.12 seconds apart. When assembled into a grid, 127 by 127, the image that emerged wasn't a map or symbol, it was symmetry itself, alternating high and low points forming a spiral similar to the Fibonacci sequence, the mathematical expression of growth seen in shells, galaxies and DNA. The pattern stopped precisely at the grid's edge, as if framed intentionally. Some saw it as coincidence, others saw it as signature, a way of saying, we understand the geometry of nature, just like you. Officially, the decoded results were archived as non-meaningful structured data. Unofficially, screenshots circulated among researchers labelled only with 3 words. They know math. The question was no longer whether the signal was artificial. It was what it wanted us to notice. And when the next detection came, stronger, closer, unmistakably deliberate, that question turned into something else entirely. Were we still listening to the stars, or had the stars started listening to us? When the Kepler and Ross signals were first logged, the story belonged to science. But when their decoded structure began circulating beyond SETI's internal network, it became something much larger, a mirror held up to humanity itself. Because what happens when "are we alone" stops being a question and starts becoming evidence? For generations that phrase lived comfortably in philosophy, a thought experiment, a metaphor for curiosity. But once data points turn into patterns, once math starts to look like intent, the implications ripple far beyond laboratories and observatories. They reach religion, government, art, identity, everything we use to define ourselves against the infinite. In the days following the leaks, SETI's public inbox received over 30,000 emails from around the world. Some were congratulations, some were prayers, some were warnings. The Vatican Observatory issued a calm but remarkable statement. If creation is vast enough to host many minds, it only deepens the mystery of its origin. The Dalai Lama called it a natural extension of consciousness, and yet political institutions froze. No world leader wanted to be the first to confirm the possibility of alien contact, because confirmation implies control, and no one had that. At the United Nations Office for Outer Space Affairs, an emergency working group convened in Vienna. It was called simply the Contact Framework Committee. Their first report was classified, but later leaks revealed what they debated. How do you respond to something that may not be human, but also may not be hostile? And perhaps more importantly, who gets to respond at all? International treaties like the Outer Space Accord of 1967 never imagined direct communication. They regulate weapons and exploration, not conversation. There is no clause for replying to intelligence of unknown origin. That legal void became a geopolitical one overnight. China's Fast Observatory, which had co-detected several of the signals, quietly paused its data-sharing agreement with Breakthrough Listen. Privately, European researchers accused the US of withholding new detections. Suddenly, the search for cosmic companionship began to look a lot like espionage. Meanwhile, the data itself kept whispering. Each new analysis revealed another layer of deliberate structure. One sequence, when converted into audio frequencies, produced harmonics corresponding to hydrogen spectral lines, the building blocks of matter. Another, when translated into base 10, aligned with orbital ratios of the inner planets. It was as if the signals were mapping our own system back to us, not transmitting from beyond, but reflecting knowledge we already had. If that's communication, it's not dialogue, it's recognition. A cosmic nod, a way of saying, "We see you." Philosophers began debating whether this even counted as contact. No messages, no words, just pattern. But pattern is how intelligence reveals itself before language exists. It's what humanity used to learn: fire, agriculture, mathematics. It's how consciousness announces its presence, through order emerging from chaos. The implications reach deeper than belief. If these signals were artificial, then humanity's cosmic loneliness was over. But so was its innocence. No longer the only architects of meaning in the void, we'd have to redefine progress, faith, and even morality under a wider sky. Economists speculated on how markets might react to verified contact. Defense analysts wrote contingency plans. Social scientists warned of fragmentation between those who would welcome cosmic neighbours and those who would see them as existential threats. In other words, confirmation of intelligence might unify us in theory, but divide us in practice. Dr. David Grinspoon of the Planetary Science Institute summarised it best. The discovery of another civilization won't destroy humanity. It'll reveal it. SETI's leadership tried to calm the storm. They reminded the public that no one had decoded a language, that all we had were anomalies. But anomalies have a way of evolving. Every new frequency spike, every repeating harmonic fed the same realization. The universe had patterns, and they were beginning to notice us back. And so, the focus shifted. Not from what we heard, but how we'd answer if hearing became conversation. Because if these patterns truly were the opening words of a dialogue, then humanity had just stepped into the most important conversation in history. In the wake of the new detections, one truth became clear. Listening was no longer enough. For over 60 years, SETI had been defined by patience, waiting for the cosmos to speak first. But what if waiting wasn't listening at all? What if silence meant we'd been using the wrong kind of ears? By 2026, a quiet revolution had begun inside the observatories. The new generation of astronomers, data native, code literate, unafraid of controversy, began building tools to see beyond traditional radio astronomy. They started fusing radio, optical, and neutrino detectors, layering multiple forms of cosmic data the same way intelligence agencies layer surveillance feeds. The idea was simple. If the universe was sending messages, they might not arrive as sound. They might arrive as geometry, light, or timing itself. One of the most ambitious projects was Cosmic Reconvergence, a collaboration between the SETI Institute, MIT's Kavli Center, and CERN's Neutrino Division. They proposed a radical experiment, synchronizing neutrino detectors on opposite sides of Earth to catch ultra-low frequency pulses that could pass straight through the planet, the kind of transmission only an advanced civilization could generate intentionally. In early trials, the detectors picked up faint rhythmic blips, one every 12.1 minutes, aligned with a right ascension near the Kepler 438 field. Statistical noise, probably, but the pattern was there, whispering again from the same coordinates where it all began. In parallel, optical SETI got its upgrade. The laser SETI array, stationed in Hawaii and California, switched from passive detection to real-time triangulation, using photon time-of-arrival correlations accurate to a nanosecond. It could now identify a laser flash from another star within one observation cycle. And on a quiet night in April 2027, one such flash arrived. A single photon burst lasting just 4.7 microseconds, matching no satellite, no cosmic ray, no meteor. When decoded into pulse intervals, its ratio matched the same prime sequence from the earlier radio data. Two different mediums, radio and light, now carrying the same mathematical DNA. Whatever was out there, it wasn't limited to one voice, it spoke in physics itself. But perhaps the most visionary leap came from Project Orion N, an initiative led by the European Southern Observatory and funded in part by private space ventures. Their goal, build an active SETI beacon, not just to listen, but to speak. A transmission architecture that could send a coherent narrowband beam toward any star system within 50 light-years, encoded with the universal constants of hydrogen, carbon, and time. A cosmic handshake offered on humanity's behalf. It was controversial. Stephen Hawking had once warned that calling out into the dark could be an invitation we weren't ready to answer. But the younger scientists countered, silence is not safety. If someone has already found us, pretending not to exist changes nothing. Better to speak deliberately than to be observed in ignorance. So the project advanced, cautiously, quietly. The transmission protocol was written, the encoding tested, the ethics debated, and yet no message has ever been sent. Every time the countdown approached zero, politics intervened. No nation wanted to be responsible for saying the wrong thing to the stars. Meanwhile, the signals kept coming. Fainter now, less frequent, but still pulsing. A pattern like breathing in the background of the universe. Each one slightly different, as though adjusting, learning, adapting to our methods. Somewhere, something was watching us watch it. For SETI, this realization changed everything. The search was no longer about finding others. It became about defining us. What do we represent to the cosmos? A species of explorers, or a civilization of noise? If contact comes not as invasion, but as comprehension, will we recognize it? At Berkeley, one researcher put it bluntly, maybe contact won't look like a ship in the sky. Maybe it'll look like data that refuses to be noise. And perhaps that's the lesson of the last half-century, that discovery is not an event but a process. A slow unfolding of awareness, each signal a mirror showing us how far we've come from the cave, from the drum beat, from the first spark of curiosity that made us look up and ask. The universe has been silent only because we didn't know how to listen. Now, with every photon, every frequency, every anomaly that refuses to fade, we're learning its language one pattern at a time. The question, are we alone, was never about others. It was about understanding what kind of beings we are. The kind who stop listening when the answer comes, or the kind who keep going deeper, no matter what waits beyond. And as the next generation of telescopes prepare to activate, the Square Kilometre Array in South Africa, the Extremely Large Telescope in Chile, and the James Webb successors already on the drawing board, one truth becomes impossible to ignore. The universe is not empty, it's simply waiting for us to listen the right way. For 60 years, humanity has been listening to the cosmos. Microphones pointed at eternity, hoping to catch a whisper in the static, and now, perhaps, we finally have. The new signals may not be greetings in any language we know. They might not even be messages, but they are proof of something profound, that the universe isn't silent, only subtle. That meaning can hide in mathematics, in patterns so perfect they feel alive. Maybe we've already been contacted, not with words but with structure, not with intent but with resonance. A mirror held up by the stars themselves asking one quiet question. Can you hear us now? The data doesn't give us answers, it gives us reflection. And in that reflection we begin to see the outlines of something bigger, a civilization capable of symmetry, patience and precision beyond imagination. Or maybe a cosmos designed to look back when you stare long enough. If these signals are real, if they are truly what they seem, then the story of humanity just changed. Because the first conversation we ever have with another intelligence might not be about who they are. It might be about what we've become, a species that builds instruments to turn silence into meaning, that refuses to accept the void as empty, that keeps listening, even when the world tells it to stop. Maybe the answer to "Are we alone?" was never out there at all. Maybe it was always here, in the act of searching, in the courage to ask, in the willingness to be small under an infinite sky and still keep listening anyway. Because somewhere, a signal still flickers. Somewhere, the math still whispers. And somewhere, someone might already be listening back. So stay curious, stay questioning, and remember, the universe rewards attention. If you felt something tonight, subscribe, share this story, and join those of us who refuse to stop listening. Because the next pattern might not just be noise, it might be hello.